So this is a quick video dealing with the properties of logs, and you will see these in Algebra 2, college algebra. You'll see them again in calculus and things like that. I'm going to first talk about the properties of logs. The first one, if I have a logarithm of any base of a product, then I can rewrite this as the sum of two separate logs, separate that product, with the same base. And I'll do an example of each. If I have a log of any base of a quotient, then I can separate that or rewrite it as the difference. Okay, the difference. So log, same log, of the top minus log of the bottom. And these are the main ones here. One more, actually two more, I'll show you this other one too, but log of any base of whatever, x to the n, that exponent, as long as that exponent is on this whole expression here, it can come to the front of the log and become the coefficient. N times log, keep the base of x. This one is kind of the same thing as 3, but particularly, the main difference is that the base of the log matches the base of this exponent, where here it doesn't. See, these bases don't match. This one does. This simplifies just into the exponent. Okay, so let me show you some properties. So you have situations where you're asked to expand or condense. Let me start with expansion. Expand the logarithmic expression. Okay. Sometimes I'll say rewrite the expression as the sum or difference of separate logs. Same thing, expanding the expression, same idea. Okay, so let's expand the logarithmic expression. Log of base 2 of 3x over y squared. So there's a few things going on here. So you're going to use a bunch of the properties. First thing, I see a quotient, right? So I'm going to start with the quotient property, which is property number 2, where I have a log of a quotient and I can separate it as log of the top minus log of the bottom, maintaining the base of the log. So I can rewrite this as log base 2 of the top, 3x, minus log, keep the base, of the bottom, which is y squared. Okay, now technically I am not done yet because I still have a product and I still have this exponent here, so I can continue to expand. Now this log here is a log of a product, so I can use this first product rule. If I have a log of a product, I can separate it as the sum. So a log of a product can become the sum of two separate logs. So I can rewrite this as log base 2 of 3 plus log base 2 of x, because this is 3 times x, so I'm separating it into the sum of separate logs. Then I'm just going to bring this part down, minus log base 2 of y squared. Now there's not much more I could do with log base 2 of 3 and log base 2 of x, but over here this exponent is on the y. This actually is this third property here where I have a log of a base. Now these bases don't match. I could bring the exponent to the front of the log and make it a coefficient. These bases don't match. The base here is 2 and the base here of this exponential is y. So I could just bring that 2 to the front, 2 log base 2 of y. So this would be my fully expanded expression. Let's do another one. Number 2. ln is a natural log. This is a log of base e. You'll see ln of the square root of x times e squared over y to the third. We'll do this one. Now you have a few things going on here. First things first, I have a quotient, but the problem with the quotient, I can't go directly into that quotient property because I have this square root on top. So if you guys remember, you can actually rewrite a square root as an exponent. of 1/2. The denominator of the exponent is the same as the index of the radical. So the square root can become an exponent of 1/2, which allows me to first use the third property, where I have a log of a base. In this case, the base is e, of an expression to an exponent. So I could bring that exponent to the front. I could bring that 1/2 to the front. So I can bring the 1/2 to the front, maintain the log. This is the natural log. It's a special log of x e squared over y to the third. So now I got rid of that exponent that's on this quotient. And now I can actually use that quotient property. 1/2 times, when I separate this, I want to make sure that that 1/2, it gets distributed after natural log of the top, which is x e squared, minus natural log of the bottom y to the third. Okay, so again, this part is a quotient. This is a log. This is like log of base e. Separates into the difference of two separate logs, log of the top minus log of the bottom. And that 1/2 is multiplied by this whole expression, so I have to keep that in front. So I put brackets here to kind of, later on I'll distribute it. To kind of remember that I would have to distribute that. 1/2 gets multiplied by everything. Now I'm not done yet, so I'm going to bring the 1/2 in front. And this part here is a product of x and e squared. E is a number, e squared. So I can rewrite that as a sum, ln of x plus ln of e squared. Then bring this down, minus ln of y to the third. So I'm getting there. I'm almost there. The thing is that I actually have an exponent here and an exponent here. But what I want you to notice is the base of the natural log is base e. And in this case, this base matches the base of the natural log. So it actually goes to this special property here where the base of the log matches the base of the expression after it. So because they match, I can just simplify that part. So here, 1/2 ln of x plus. I can simplify this into just that exponent 2. Again, that's property 4, where the base of the log matches the base of the expression. It simplifies into the exponent. The natural log is base e. This has a base of e. So they match, so it simplifies just into the exponent. Minus, this one's different because the bases don't match. Because the base of the log does not match the base of the expression, I'm going to bring that 3 to the front and say 3 ln of y to the third. So this is technically all I can, 3 times ln of y. I already brought that 3 to the front, right? So that exponent disappears once I bring that to the front, okay? Now I see no more, multiplication behind a log, no more division behind a log, no more exponent. So now I'll finally just distribute this 1/2 to every term. And I will end up with 1/2 times ln of x. So we write that as 1/2 ln of x plus 1/2 times 2, which is 1. 1/2 times -3 is -3/2 ln of y. And this is my completely expanded logarithmic expression.